Okay, so I'll be going over my solutions to Codeforces round 629. So for problem A, we want to get from A to a multiple of B, and in order to find the number of moves, we subtract A from B, and then we take the result, we take the remainder when divided by B to find the number of moves. But then in some programming languages, this is negative, so then when you take the mod, this expression will be negative. So in order to make it positive, we need to add b first and then take the mod b again in order to get the answer. And so this problem is really just about manipulating expressions with modular arithmetic. I think it comes with its intuition really helps, and it comes with practice. So for the second problem, so the string always starts with the first character at the first character always starts at position n-2, and then it goes to n-3 and then n-4 all the way until 0. So we'll start with we'll iterate over the first character, and it starts at n-2, and then we check if the kth string has its first character at this position. So in order to do that, we find the number of strings with the first character at this position, and the number of strings which have the first character at position I is exactly n-1 minus I. And that's the number of choices for the second character. So if k is less than this number, then we know that I will be the first position of the B. And otherwise, if k is greater than or equal to this count, then that means I is not the position of the first character. So we just subtract 1 to I again and move on to the next I. And then if we find out that I is the first position, then we set the first position to I, and then out of all strings with the first position equal to I, we want to find the kth string. And if k is 0, then the second character will just be the end. It'll start from n-1. And then if you increase k, as you increase k, the second character will move forward until i+1. So the expression for the second character is n-1 minus k. And note that I subtract k by 1 in the beginning. So, and then we just output it. So it's the first position or the second position, we output B, otherwise we output A. Okay, so for this problem, okay, so first off, if we have a character with, if x has a 2, then we only have two choices for A and B. A and B can either be, actually we have three choices, so A and B can be this, or this. And then if A and B is 1, then we can either choose this or this. And notice that we won't choose this, because if we choose 2 and 2, then we can always change it to some other pair to get a better answer. Remember that we need to minimize the maximum of A and B. And then if it's 0, then it's just 0, 0. And then even though we can put 1, 2 or 2, 1, by the same reasoning as this, it's never optimal to put these two pairs when we want to minimize the maximum of these two numbers. So basically, actually I can Okay, I'll change my code a bit here to make it more understandable. Okay, so if this is true, then actually never mind. I'll just explain this. Okay, so at the start, A and B are both they're both empty, and we start from the first character, start from the leftmost digit of x, the most significant digit. Then initially this boolean ch, it means whether A or B are different. So since at the start A and B are the same, we set ch to 0. Okay, so let's look at the cases. Okay, so when the character is 0, we only have one possible choice. And when the character is 2, if A and B are still the same, then we will add 1 to both strings. Note that we don't add 2, 0 or 0, 2, because if we do, then the maximum will be of these two characters, the maximum of these two strings will be 2 instead of 1, and then you want to minimize the maximum, so that's why we choose this. Okay, and then when the character is equal to 1, then we give 1 to the first string and we give the character 0 to the second string. But then after this operation, A and B become different. So if A and B have not been different before, then we'll set this flag and to make sure that we know that these two strings are different. And then we'll swap A and B. So now, because A is the one that got added to 1, and after we swap them, A will be the smaller string and B will be the bigger string. Okay, so after this happens, A will look something like this. A and B have the same prefix, and then A will have a 0 in the front, and then B will have a 1, like this. So now the maximum of A and B must be B. So now we just need to focus on minimizing B. Okay, so after A and B are different, we want to focus on minimizing B. So when A and B are different, so for this pair, since we want to minimize B, we give the 0 to B and the 2 to A, because we don't really care about A. And then the same thing happens for when the character is 1. So we still want to minimize B, so we give 0 to B and 1 to A. Lastly, we just output these two numbers. Yeah, okay. Okay, for problem D, the first case we need to take care about is, okay, so for the input, I make the array circular. So what that means is I create an array which is 2 times the size, and then I set a of I plus n to a of I. That way, the array kind of becomes circular and it makes the implementation slightly easier. So the first thing I need to check is if all adjacent pair of elements are different. And if it's true, then this if statement will run. And we have 2 cases. So the first case is that n is odd. So if n is odd and all adjacent pairs are different, then that means every adjacent pair has to have a different color. So if we assign this 1, this needs to be 2. And we can actually view this as like graph coloring. So we have edges between 2 nodes if they have different colors. Then we need to make sure that the different types are assigned different colors. So after we do this, if n is odd, then for the last element, we'll need to assign a 3. So for the first n-1 elements, we assign 1 and 2 repeatedly, and then we assign 3 in the end. And then when n is even, we only need to use two colors like this. So we just assign 1 and 2 alternatively. And yeah, so this is a case when all adjacent pair of elements are different. And that's the only case we will have a cycle. In all other cases, so maybe in some case, maybe these two elements are the same. So that means that these two elements cannot be connected. So the most we can have is just a path like this. And if we just have a set of paths, then that means the graph must be bipartite. So that means you can use at most 2 colors. And the answer will be 1 if all nodes are the same, so that there will be no edges. So first I find the start of the array S. So what I mean is, let's say this is node, this is the first animal, and then maybe the edges look like this. And what I want to do is I just want to find the first element in this path, and then I'll set this equal to S. So that's what I do. Well, the previous element of S is different, then that means they have an edge, and I'll just decrease S. And then I'll find the ranges inside the array which are such that the adjacent elements are different. So J starts at I plus 1, and while J is different from the last element, then I'll increase J. And then the total number of colors we need for this path is it's 1 if the length of the path is 1. Otherwise, it's 2 if the length of the path is greater than or equal to 2. So this basically updates the answer. And then for each node in this path, I set the first node to 1, the second node to 2, and so on, using this formula. And then lastly, I just output the answer. Okay, problem E. So we want to find if there's some path from the root to vertex U such that each of the given vertices either belongs to this path or has the distance 1 to some vertex of this path. I actually don't know if there's an easier solution to this, but well, actually, oh yeah, okay, I'll describe my solution I came up with in the contest first, which uses lowest common ancestor, and then I'll describe the solution without lowest common ancestor. Okay, so we have a tree. This is the root node at 1, and then I want to see if there's some node U such that like all selected vertices belong to this path from U to the root, or it has distance at most 1 from this path. And my code here in the DFS, I have this part where I calculate the depth of each of the nodes. So when for each query, I input the vertices, and then I sort the vertices based on their depth. And I don't actually need to sort, I just need to find the vertex with the maximum depth, because if there's a path for some U, then the U will be the vertex with the maximum depth in the set of the given vertices. So yeah, so if these are the given vertices, then I just choose the node with the maximum depth, and I set that to U. And now I need to check that, I just need to check that all nodes are within distance 1 from this path. And in order to do that, just go through each of the nodes except for the node which is U, and then yeah, and then I somehow check each path to I somehow check U with the node to see if I somehow check the node to see if it's within distance 1 from the path. So in order to do that, we can, so if this is v, and first I find the lowest common ancestor of u and v. And let's say this is w. And if now we compare the distance between v and w. And if v is on the path from u to the node, then v should be equal to w. So they should have the same distance, the same depth. But otherwise, if v has a distance at most 1 from the path, then v should have a depth which is at most 1 from a w. Then v should have a depth which is exactly 1 more than the depth of node w. So in order to check if the node has a distance at most 1 from the path, we just check that the depth of the node is at most 1 plus the depth of the LCA. And yeah, in DFS here, I also calculate the binary lifting table, and then this LCA is the standard binary lifting algorithm. And then if you don't know about LCA, that's okay, because what you do is you can just check if there are 2 cases. If v is an ancestor of u, then you just check if v is an ancestor of u using DFS order. And then if v is not on the path, then all you do is you take the parent of v, and then you want to see if the parent of v is on the path from u to the root node. So you just check that the parent of v is an ancestor of u. Then just check these 2 cases. If one of them is true, then v has a distance of at most 1 from the path. And if none of these conditions are true, then v has a distance greater than 1 from the path. Yeah, okay, and then last problem is problem F. So first, let's sort the array. And then, let's say that in the array we have some range of equal elements, and the value of these elements are equal to x. And then the count of these elements is c. So the first thing is, if c is greater than or equal to k, then that means we already have k elements, so the answer is just 0. Okay, but if c is smaller than k, that means we have to make some elements in the right. In order to make the element with value x have a count greater than or equal to k, we need to make the prefix, we need to turn some elements in the prefix into x, and maybe some elements in the suffix into x. So how many moves do we need to turn some of these elements in the prefix to x? Well, if we consider, let's say x is equal to 5. And then in the array, in the prefix, we have 1, 2, 4, and then 5, 5. And then the rest we don't care about for now. What will happen is this will increase into 2, and then after that, these 2 will both increase to 3 with 2 operations, and then these will both increase to 4. So before any prefix of these elements turns into x, they all become x minus 1 first. So we can calculate the number of operations required to turn the entire prefix into x minus 1 with a formula. So the formula is just the number of elements to the prefix, which is I, multiplied by x minus 1, minus the initial sum of the prefix. And I calculate the initial sum using prefix sums. And then this will give me the cost I need to turn the prefix into elements of all x minus 1. And then, yeah, so this is the first case. If we want to make elements into prefix, if we want to turn into some elements in prefix into x, then they must all become x minus 1 first. And after they become x minus 1, then for one operation, I can turn them into 5. Yeah. So the first case is if we just use the prefix on the left, then we check to make sure that the total count of the original array plus the count of the prefix is greater than or equal to k. In that case, we can just use the left prefix to get a count of k elements. So the answer for that will be the cost we need to get all elements in the prefix to x minus 1, and we also add a cost of 1 for each additional element that we need in a prefix to be turned into x. And then we also do the same thing for the right side. So before any elements in the suffix become x, they must all become x plus 1 first. So first I calculate the cost of turning all elements in the suffix into x plus 1, which is just the sum of the suffix minus the count of the number of elements in the suffix times x plus 1. And then, yeah, I do the same thing for the right side. Yeah, it's pretty much the same. And then there's also the case when we convert elements from both sides. So in that case, we add the cost of the two sides together, and the cost of turning one element into x is still 1. So we add k minus c. And then there's the case when if k is less than c, then this could become negative, which doesn't make sense. So we have to take the maximum of answer with 0. Yeah, that's pretty much it. So if this video was helpful for you, then feel free to like and subscribe. And if you have any questions, then you can ask them in the comment section below, or you can go in the description of this video. I included a link to a new Discord server that I made. So you can join that and just discuss or ask for help there if you have any questions. And yeah, thanks for watching.